Scheiße!
Warning, the device showcased in this video works with not only mains voltage, which is around 230 volts here in Europe, and also high voltage to power the CRT around 25 kilovolts. Tampering with such high voltages can kill instantly. Also, this device contains toxic substances such as beryllium oxide. Beryllium oxide can cause you lung cancer in the worst case scenario. In the solid form, like in this oscilloscope, it is practically inert, so be sure when you're handling a piece of old equipment like this and you find mysterious white blocks which are a bit transparent when you touch it, your hand gets super cold. Be sure to handle it with care and dispose of the discs if you can. Anyways, now let's get back to the video, and I hope you acknowledge this. Oh, and yeah, tamper with this thing at your own risk. I don't take responsibility for any injuries because it's your fault if something happens to you. I'm warning you right here.
Okay, so hello again guys, it's Sonic the Hedgehog and welcome back to another teardown video. Just as a little disclaimer, I'm not filming on my bench because have a look at that cluttered mess. I still have to clean that up, so that's getting worked on, as well as I'm not putting my costume on because I'm way too tired to make a proper video. But the thing that we are tearing down is one of my Christmas presents, and it's a Tektronix 453 oscilloscope. Apparently it does not power on, and it apparently has been damaged by some sort of line surge, by a really high voltage surge. Which I think that's a bit of a problem because the transformer might be blown in that thing. I don't know. We'll check the fuses just to see if they are fine. But anyways, this is a 453A, as I said, and there's a really easy way to differentiate between the 453 and the 453A, and that's that the A variant has a blue screen, rather than the standard 453 has a white screen. Now, on the camera, it comes out as a nice sort of movie Sonic blue, but if you have a look at it in real life, it is actually a bit turquoisey. So, yeah, just to tell you that. It is in really nice shape. This one is in a really nice shape. It is almost in museum shape. There is pretty much no scratches on the cover whatsoever. The cover is in mint shape. None of the controls are broken off. All the controls are fine. None of them are broken off. Doesn't look like any of these switches have been super glued back on. And when I first saw it in the listing, because I'm supposed to pick a present for grandma, and I picked this one, and Grandma was pretty surprised at this. She didn't know what it is. It's an oscilloscope designed to measure signals and stuff. Anyways, I thought that first these knobs actually had the caps missing, but by looking at them closely now, it looks like they have just black caps, which is pretty neat. Anyways, let's have a look at what we have on the front panel. Oh, should I say the specs? The only specs I know about this is that it's possibly a 50 megahertz. The standard 453 is a 50 megahertz bandwidth. It's an analog scope. I don't know what the A variant has. Maybe it will have a higher bandwidth, possibly, because the A variant, and I'm actually noticing there is some dents in the cover, such as here or here, but still, it's in great shape. There is not much dust on it. Dad said that it was horrifically dirty, so he prepared me to take a vacuum and all different wet wipes to clean it off, and I unpackaged it, and voila, it's clean. There's a fan in this thing, and I don't think that the heat sinks behind that fan are clean. But just before we have a look at the front panel, this thing is rattling, and it looks as though that two of the three bolts on the fan are missing. So the fan is only being held on by a single bolt, which is not really that great. Anyways, I've got it on this suitcase because I'm filming this in my bed. I'm a bit sick. I don't feel good, but yeah. It's really easy to rotate the thing. This thing weighs a ton. It is portable, though. It's got a handle, and you can flip it around to the front or to the bottom if you want it as a stand, or you can flip it around to the front, and you can carry it like this. It's a really comfortable handle, but it still is not that comfortable to carry because it weighs a ton. Anyways, let's have a look at the controls. So we've got the power switch right here, just a standard toggle switch with your power indicator light. Next, right here, you've got the CRT controls, such as the intensity, focus, scale illumination, and the beam finder. It's a really nice switch. Right below here, you've got your you've got the controls for your two channels. You've got the channel 1 and channel 2 inputs. Right next to that, you've got step attenuator balances. There's also a ground terminal right here for grounding of the probe, I guess. Next, right here, you've got uncalibrated lights, which have something to do with these variable knobs on these. This is, by the way, your volts per division. You just tweak that to select your volts per division. you know. Right here are your position controls. And what's interesting is I didn't know what these VAR knobs, they seem like variable, what these variable knobs do on the volts per division knobs, but there are these uncalibrated lights, which I think these might be to calibrate it. I don't know. Next of all, you've got your gain potentiometers. Next, you've got your some sort of switches on both channels, which is between AC, ground, and DC. Sorry that I keep flipping these switches, but it's so neat and it feels so good. Anyways, next to all, we've got your mode switch, which I guess is just like what will be displayed on the screen. And that goes between channel 1, channel 2, alternative, chop, and addition. And next we've got another small switch, which switches the internal trigger from between normal or channel 1. Next you've got this pull switch, which says invert, pull to invert. I don't know what you would invert with that. Doesn't feel that amazing though. Next, right here is your time base. I mean, that's a pretty nice decisive switch, I'd say. That feels really nice. Next, right here, you've got your A sweep length. I know what that does. You've got your position, which is fine on this bigger knob and, of course, on this smaller knob. Next, right down here, you've got your A triggering, which you've got the A sweep mode, which is auto trigger, normal trigger, or single sweep. And then you've got your reset switch right there. And at first I thought that was an indicator light, but that's actually a button. Next we've got your level right here, which is the bottom knob, and the top one is high frequency stab, which I don't know what that does. Next you've got your slope, plus or minus, coupling AC, low frequency, high frequency DC, and your source, which is internal line, external divided by 10. And these two modes go to this external trigger input, and of course you've got your channel 1 indicator light. Next, right up here, you've got your B triggering, which has, of course, you've got the level now, but you don't have any kind of that high frequency stab. You've got your slope, coupling is the same, source is the same, and the same channel 1 indicator, and of course the same input. Now right here is something that I truly love about this scope. It is the delay time multiplier, and that is a vernier. And that feels, guys, I wish there was Philo Vision, because this is one of the best feeling knobs I ever had. This is one of the best knobs I ever felt. Seriously, this feels so neat. Anyway, so right here you've got your B sweep mode, which switches between triggerable after delay time and B starts after delay time. Next you've got your horizontal display, which is A internal during B delayed sweep, mixed, X or Y. X where you've got your mag, which is off or times 10, indicator light of course under that. And next, you've got your A sweep triggered and uncalibrated A or B indicator lights. And that's pretty much it. Oh, sorry, I almost forgot. You've got your 1 kilohertz calibration signal, because what that's for, easy. You would connect a BNC cable onto this, and you would then link that cable to, for example... Shut up, Apple Watch. I hate this when it fucking keeps interrupting me in a video. Also, I hate Hey Siri, because that phrase, it is just so janky that Siri keeps activating when I say completely different word than her name or hey. I don't know. Anyways, sometimes it doesn't even react when I say deliberately. Anyways, the calibrated signal works like this. So you plug a BNC cable into this, then connect the other end of the cable into the channel 2, for example. Select the channel 2 on here. Select your words per division and your time base. That is just pretty stiff, but it is what it is. And also on the time base, you've got the variable knob again. You know what that does. Anyways, and then you'll get it displayed on the channel. Likewise, you would do for channel 1. Switch it to channel 1 and do all the tests. Anyways, now let me flip this around to the other side. I don't really want to make this in a million different videos, because because I gotta make the editing simple. Just editing my videos has become more complicated, because I want my channel to be high quality and I have to wipe my lens off. Anyways, I want my video quality to be better, and just the editing, it takes some time, and also I have to upload the videos to my computer, and it's just super annoying. Anyways, right here you've got some other controls, and let me flip this handle down to the front. There you go. This is how you would carry it, by the way. So, right here you've got some connectors such as the A gate, B gate, and the channel 1 output. You've got your probe loop. I don't know what that does. You've got some calibration inputs such as the A-stig and trace rotation. You've got your calibrator, which can be selected between 1 volt or 100 millivolts. And next of all, you've got your variable, which, oh, that's B time per division. That's your B time base. I don't know what that does. Anyways, let me flip this thing over to the back. Oh my god, this thing weighs a ton. Don't even ask me how much this thing weighs. It weighs about 13 kilos. It's still, I mean, it's still lighter than the Czechoslovakian scopes that I have here in the Czech Republic. Anyways, right on the back here, you've got your input right here. Next, right here is your is a line voltage selector. The frequency is 48 to 62 hertz. So right here is your line voltage selector. It's of course selected to 230 volts and the medium range, which is 208 volts to 252 volts. Because I live in the Europe, especially Czech Republic, which is in the middle of Europe, and we use this voltage. And our electrical system isn't as dangerous as the American one. And we don't have houses, but a lot of have a listen. This is not wood. Anyways, let me just unscrew the front here, so that way we can, by the way, houses, all the houses that you see outside of here, all the houses, they aren't wooden. Fun fact. Anyways, Europe is much better than America. Anyways, let's just lift this out. So, okay, so here are your fuses. We'll have to check those. I should just do a visual check because my multimeter is downstairs and I don't want to run for it, but let's just do a visual check on them just to see in what shape they are. One moment, please. I should just lift the fuses out. Ugh! Jesus Christ. Yep, that one seems to be fine. Clip it back in. The other one? The other one is also fine. So the fuses are okay. There might be some more fuses on the inside. Anyways, already is the selector. This is how you'd select your line voltage. Just flip that around. There you go. Now, here's your voltage region. You just kind of, you know, do that. It's pretty nifty. So let's just plug that right back into there. The video is already 10 minutes long. This will be a heck of a long video. And this thing will be probably full of stuff. Anyways, right here is your cooling fan. I'm unfortunately missing the filter on it, but it is still pretty darn dirty in there. You can see that it's a standard 4-bladed Bakelite fan. So possibly sticking something in there whilst it's spinning would probably break the blades. Let's just try and spin it. Yep, it's free to spin, fortunately. Anyways, I think somebody tried to get the fan out and didn't manage to screw all the bolts in, because if it was just bolts and there weren't threads in the metal casing, well then, that would be pretty complicated, because I guess that there must be some sort of electronics in there and they might be hard to take out, so nobody wanted to destroy this. Here's your Z-axis input and your grounding again. Oh, that's in German. I'm Czech, so I don't know how to read German, but it passed the line test, maximal 14 kilovolts? Huh, I don't know. Anyways, now, guys, let me get this thing open and we shall see what's inside. One moment, please. Okay, so here we are. I managed to get this thing open. It was rather easy. You just unscrew these 2 bolts on the sides and then both the covers just come off. And man, would you have a look at this. I mean, this is one of the neatest appliances, devices, should I say, I ever took apart. Let's have a look on the other side. Oh my good lordy Lou, there is a ton of stuff in here. By the way, I also took apart the high voltage section right here, as well as that shielded section up there. So we could have a look at that, and man, there's a lot of interesting and nice stuff in here. But first, let me flip this thing over to this side, so that way we can have a look at the input circuitry. So here's your main transformer. And the input from the transformer first goes through a primary fuse, then goes into the transformer. And what's interesting is they've got metallized film capacitors across each. They've got film capacitors across each winding, which is interesting. And next you've got a secondary fuse, and that then comes out of the looming. And I mean just on the looming. And I mean just look at the looming. I mean it's nicely loomed together, and the wires come out of the loom at the exactly right spot, just connect to the board. Oh, that's so neat. Anyways, it looks like you've got 4 filter capacitors in here. Sprague. I mean, those will be probably top quality, if I was to be asked. Right in here, it looks like you've got your time-based switch and stuff. This looks like the potentiometer for the variable up here, I would take a wild guess. Possibly. Anyways, let's start having a look. Let's start looking at the boards. And the first board is right down here. And on this board, there ain't really that much. It's still pretty complicated for back in the day. all the boards are obviously gold plated if you haven't noticed already. So right here are a ton of different capacitors. You've got about a couple of electrolytic capacitors. Those are obviously Sprague. You can see right there, that one is a Sprague. Got some of these trimmers. Those will be possibly high quality, very high quality. First time I ever see a trimmer like that. Hands up if you've seen one of these. I mean, it's the first time I ever seen this kind of form factor. And right here is, what is that, capacitor? No, that's a diode. Don't be fooled, guys, that's a diode. Some sort of really germanium diode is possibly, because those are silicon diodes. Right, they're very early ones. Look, they are reminiscent of the solid ones. These are very reminiscent. This package is very reminiscent of those really early Czechoslovakian or Soviet ones. I know that because I took apart a lot of Czechoslovakian Soviet stuff, because here in the Czech Republic and Slovakia there was communism and just nothing else really was here. So it's pretty interesting that in the communistic era of Germany, which is where I got this one from, that they actually were able to get this, because dude, this is like from the early 1970s. I would take a while guess. I mean, the board is copyrighted 1965, but this unit right here is from the 70s because it's the A variant. Looks like the board is labeled for the A variant. Looks like it's type 453A, and then that's copyright 1970. Anyways, you've got a ton of different transistors. You've got these sort of resin potted transistors, and next of all you've got these transistors right here, these sort of metal cased ones. Let me stuff that right back in there. What is that one? That's a Motorola. Yes, that's a Motorola. That is possibly an RCA. So yeah, some resistors on here, a ton of different resistors. And nothing really else on this board worth mentioning. Metallized film capacitor, of course, some ceramic capacitors. That's it. What the fuck is under there? Have a look at that, guys. I'm just gonna try and do it like that. Have a look. Looks like you've got some sort of device. This looks like some sort of NASA space equipment, this right here. You've got some sort of devices, possible transistors, and some sort of weird bolt case bolted to a heatsink, which that below there is where the fan is. There's looks like some really high power transistors under that as well, and those are just gold plated. That one is a bit tarnished though, and the leads just run off somewhere else inside, and oh, it is just so neat. Anyways, right here you've got the horizontal amplifier board, and on here you've got some of these really high quality Allen Bradley potentiometers or trimmers, and guys, Sonic spotted something very sinister. That ain't your standard ceramic. If I'm gonna touch that, yep, that's confirmed. It's beryllium oxide. And beryllium oxide is a rather toxic substance that in worst cases can cause you lung cancer. But even if I was to scrape a little bit of this off and breathe it in, I'll be probably fine. At least for a couple of decades. Anyways, right here we've got some transistors around here now. In that beryllium oxide, there are these sort of weird components in brackets, which I think they are made by RCA, and I guess that those are some sort of transistors. They look to be connected to the cathode ray tube, so I guess that those might be doing something with the deflection. No, the deflection. What? Wait, there is a big old connector on the back of here, so is this the deflection? That must be the deflection, surely. Here's your cathode, by the way. So, that is the deflection, I guess. Ton of resistors across here. I mean, look at those. Those are pretty big resistors. Transistors, and not really much else. Under here, we've got a shield. You can see all the looming. You've got some sort of coaxial cables on here, which I guess to deal with the RF. Of course, a ton of transistors around here. I mean, what would you expect? I'll give you this. I'll zoom in on one of those transistors if you want to have a look at what I'm talking about. Right there. What is that? Is that a TI? No, that's not a Texas Instruments. That is something very different. These things right here aren't really resistors. Those are capacitors, tubular capacitors, and you would see a lot of these in old Soviet equipment, but right here I see them in a piece of American equipment. Anyways, these are basically ceramic capacitors, but most people actually don't really know that these behave radically differently from ceramic capacitors. Like in RF circuits, in standard circuits they behave the same, but in RF circuits, that's where you normally use ceramic capacitors. That's where they behave differently. You also use these in high voltage stuff. Next, you can see right here, this sort of jumper link with this ferrite bead around it is used for interference suppression, I think. Got a Looks like yep, a ferrite around that. And uh-oh, guys, I spotted something very sinister as well. Let me zoom out. Let me just get close to this section right here. And let's just now, guys, let you find out where is the sinister thing that I'm talking about. It is that thing right there. Let me zoom up into it, onto it, should I say. Now, guys, correct me if I'm wrong here, but that thing right there is a tunnel diode. And if that is a tunnel diode, well, in that case, that practically means that that's another source of a failure. Well, we'll get under that ceramic capacitor. I should just bend it up there a bit. This is a little, looks like a little transformer. Pretty interesting. And it's right up here. We've got, again, one of those, they are labeled circuit trim. One of these sort of weird potentiometers. We can have 4 of these right down in here. And 3 of these down here, so we've got a 4th one right here. Of course, a ton of these other Allen Bradley trimmers. Transistors everywhere, pretty much. And another transistor right there. That is a really old one. Yes, resistors, of course, capacitors. All the stuff you could possibly dream of to find in something like this. Is there anything relevant? That's a really early, that's a germanium diode, I believe. That's a germanium pulse diode. And yeah, we've got a Dixon capacitor right there. Dixon. Don't really ask me, well, what reference that could be. Anyways, there is a twin diode, looks like. And a single diode right down there. Let's have a look let's have a look up into the control section right here. So here's your vernier. It's a Bohrens vernier, which means that it will be probably top of the line. Here are your switches. Let's have a look at those. Oh my god, that's a mechanical switch porn right there. Check that out. That's neat. Some tubular capacitors across there. A ceramic. Looks like a resistor. And it looks like that we should be able to just lift this panel out. If I could unscrew that screw, it looks like it's on a hinge, a really good quality hinge. So I think that if I can just unscrew that screw, we should be probably able to just take that out. Yes, no, my screwdriver just fell off the screw head. Oh, there we go. I loosened it. Now I think I have to twist the handle forwards. One moment, please. I twisted the handle. So now, my raccoon. That was a good joke, wasn't it? It was a really bad joke. Anyways, right here, let's just lift that open. And oh my god, there's a ton in there. Okay, let me hold this up somehow. It is really hard to do with just 2 hands. With 1 hand. Anyways, right there, look at that trimmer. That is a big ass trimmer. What is that? What the fuck is that? That looks like a capacitor. And you've got 2 of those things. Those look like some sort of other type of capacitor. I don't know. Here are your here's your time-based switch, that big one right down there. That looks like a horizontal display switch, and that's pretty much it. Let's have a look at on the back of this thing. What we have? You can see that just right there. Yes. Here's a switch. There you go. So yeah, now let me screw this back in because I want to keep this baby together. So where is my screwdriver? Where's my screwdriver? Where is it? It was my only flathead screwdriver I have here at the moment. Yes, I don't have flathead screwdrivers. What do you think, guys? This thing is full of Phillips screws, and seeing a flathead is pretty out of place in here. Let's just screw that back in. There you go. So yeah, but now let me turn this all the way back to the top. Already 10 minutes into the video, and we are in discussing shit up. You know, I just can't talk. Anyways, right here are some gold-plated screws. That's pretty niche. Anyways, we just... Oh my god. Oh yeah, here we are. So here's our cathode ray tube. This is our possibly the heater. This is the cathode heater. This I would take a while to guess is the cathode. Got the cable running in there. Let's try and lift it out. Yep, it just comes off. That's our cathode right there. So guys, I need 2 hands for this. Get in there, you bugger. There you go. Now let's get this cap on the top of it. There you go. Get in there. What is your problem? Here we are. It's in there. Now right here are your CRT controls. Those are just standard potentiometers. Nothing really else there interesting. This one looks to be one of those Allen Bradley trimmers, but I didn't know why this one has a longer shaft and is shielded. because it's got coaxial cables. Oh, are those coaxial cables? I don't know. Right here's our beam finder switch if you want to see some mechanical switchboard. Have a look at that. It's not moving really much. You should be just able to see it. Right here is your volts per division switch. Let's try and that's the trimmer right there. That one. I don't think I will be able to spin that, but let me spin the volts per division. You can see the volts per division switch actually moving. Wow. And right there is a coupling which seems to lead to the variable potentiometer, to the variable knob. And now let's have a look at how that works. Oh my god! That is really neat. I mean, I can't even complain. That is super neat. Now that weird coil that you see down here is a delay line, and that's how you get your delayed sweep right here by the vernier. So yeah. Here's just a ton of cables coming through here. And the clear one, which looks like a hose, is actually a cathode. What is that? What the fuck is that? I need you to focus right in there. See that sort of weird coil in there? It's really hard to see because it's fucking focusing on the wrong thing. That thing right there, what is that? What is that? I don't know, and I think I'll never know. Because these things are so mysterious. Anyways, already you've got another board. It's labeled HC. And on the board you don't have much. You've got an Allen Bradley trimmer again. You've got these very, very, very early variable capacitors. Transistors all over the place. Is that a TI? Is that a Texas Instruments device? That's a very early Texas Instruments device right there. Next, it looks like you've got two, again, more beryllium oxide. That's neat. More cancer substance. And it looks like you've got two transistors on there. Again, those RCA ones. You've got some inductors on here. What are these? They're labeled Tektronix. So Tektronix rolls their own capacitors. Oh, those are resistors. 650 ohms. Looks like there's a ceramic capacitor right there. There are some inductors on this board. It looks like a couple. And that's pretty much it on this side. So let me now flip this entire thing to the back. Oh, sorry, I keep forgetting. You've got your Y-axis alignment pot right there. So your trimmer, you would go in there with your screwdriver, tweak that with your tongue in the right angle. Anyway, so now let's have a look at the back section. And first thing that I noticed is they have replaced transistors in here. Somebody's been doing a job to this. Somebody was trying to repair this, and it, for all intents and purposes, looks like that somebody just tried to replace transistors. Let's try and take one of those out, see what kind of gold-plated legs. Jesus Christ, what are those? Motorola. Where's the date code? Looks like they're from the 1970s era, so let's just leave those back in there. I guess that these are supposed to these belong to this oscilloscope. Anyways, like, look at this spicy ass high voltage section, or this RF business up here and all this. This is just a fucking interesting and neatly done oscilloscope. I just love this thing. This thing is absolutely full of mysteries, of unknown stuff, and just look at all the different parts in here. It's just, they don't make them like this anymore. And if you open the service manual, they actually explain how each board works and explain each component. And it's just so great. It's such an shame that they don't make these like they used to. Like, they would just... Like, Tektronix doesn't make scopes as they used to. Well, anyways, look at the insane numbers of the insane wires going down the back there, which I guess goes to the cathode ray tube. So yeah. Next, let's have a look at this board right down here, which is labeled, I don't know, it's labeled H, and I don't know what that does. Hi, Hedgehog. I guess Hedgehog, the Hedgehog board. No Sonic jokes right here. Insert a Sonic joke right here. I'm not putting a Sonic joke here because I'm not a Sonic hater, and I love Sonic. Probably noticed that already in my if Andrew, if you're watching, you know that already. Anyways, let's have a look at what we got on this board. So it looks like we've got two trimmers. Oh my god, dude, that's an artifact. Have a look at that. That is an artifact. That is a true logic artifact. That is a transistor made by Texas Instruments. I think I've never seen transistors built by Texas Instruments. There's one smaller one by TI. There was another one on the other side. Let me zoom out for this. I think there was one right here. Was it right here? On this board? I can't spot it. Oh, it was right there. Yes. So you've got 3 different Texas Instruments devices on here. You've got a bank of ceramic capacitors, it looks like. Yes. You've got 2. You've got like 2 more transistors. These are, I think, Motorola ones, and I guess that these are the original. They might be, but they like out of place here. But they are Motorola. They've got gold-plated legs, and they seem like they're decent quality. So I shall just trust them. Tubular capacitors. Oh, that resistor seems like it has gotten hot, like really hot. Next we've got your 2 different big-ass resistors. That is just something truly, isn't it? A ton of ceramic capacitors around here. Metallized film capacitors. Jeez. You've got a ton of different stuff on here. Again, a gold-plated screw, and just look at those wires going into that. I mean, that's just gorgeous. And look, that ceramic insert is so nice. I just can't believe what Tektronix just and all different manufacturers of test equipment. Why don't you make test equipment like this anymore? Now it's just all in a single chip on a board. It's sad. Anyways, yeah, so this is pretty interesting. Definitely really good quality. I mean, look at those wires. Look at all those wires going right down into the back section. I don't think that there is a PCB in there. There's just a couple of components in there, like a transistor and a fan and a couple of resistors, capacitors, and inductors. I don't think I'll take the back off. It looks like it is held on by some really big screws, and it looks like it might be, I don't know, like it looks like it's pretty stiff to take out, and I don't want to damage this, so sorry. Diode right there. So yeah, now let's have a look at this board, which is the A trigger board. On the input, looks like we've got a transformer, and by the way, that text, that's not my camera going the fuck A. That's just the printing on it. Next of all, you've got a capacitor on the top of here. Looks like an asphalt capacitor to me. Might be. Like, it's really old. Some transistors on here. Looks like you've got a resistor behind there. This thing is just full of this has a ton of components in it. Oh, Allen Bradley trimmer again. And here you can see the Allen Bradley trimmer. It's right on the top there on the step attenuator balance. You can see the Allen Bradley logo. I've got an Allen Bradley PLC somewhere. I think it's in the attic. When I'm gonna be cleaning the Christmas ornaments back up and putting them back into the attic, I'll see if I'll search for it. Anyways. Right here are some transformers, some really tiny ones, a ton of transistors around here, and and another tunnel diode. Which is not good. That's no good. That's no good. Anyways, Sonic the Hedgehog would say. Anyways, look at that. Oh my god, that's just like, just focus. Oh my god, you nasty. There you go. So right here, you've got a germanium diode and a resistor just soldered together like nothing's ever happened. That strangely looks like a resistor, but it's an inductor. And it looks like all the different components are color-coded. Like, even the capacitors are color-coded. I don't know. Heck, like, is that the same color code as resistors have? But the multiplier, because, like, resistors are in ohms, and capacitors are in farads. Which, like, I don't know what the code would be, what the multiplier would be, so that would be pretty hard to figure out. Good thing that I don't have to figure it out. Anyways, it looks like another tunnel diode. Correct me if I'm wrong here, but I think those are tunnel diodes. Oh, look at that capacitor right there. Looks like it has got 2 boards in it. This is a Sprague, and it looks like it's got 2 discs in it instead of 1. Looks like again another ton of capacitors on there, resistors behind there. I mean, yeah, you can see again the switches if you want to have a look. That's just absolutely gorgeous, and these switches feel really neat. That's your button right there, and that's your level and high frequency stab right there. And yeah, you've just got a resistor which taps off there across to there, and they don't make them like this anymore. And there is something really neat about these old designs. You've got this, again, this really old Tektronix diode. Again, those jumpers with the ferrite beads on them for interference suppression. More resistors. I mean, yeah. Guys, what do they need a neon bulb on the trigger board for? I guess maybe protection, maybe. Look at all those connectors. I mean, that's just gorgeous, totally neat. I mean, they don't make them like this anymore. I'm really sad because, like, dude, this is so neatly done. It's neat and tidy. There's no mess in this. The service manual tells you how everything works, what components you have to buy as a replacement. It is great ass. Anyways, now let's have a look at the main RF business, which is... No, let's leave that for the last, and let's have a look at the high voltage section. So this high voltage power supply right here is, if you don't know electronics, and you should know that, if you are a beginner to electronics, you should know that a high voltage power supply, this high voltage power supply is used for the cathode ray tube, because cathode ray tubes need high voltage to work, in order to work. Anyways, right here is your core, core element of this high voltage power supply. This is a transformer. Right here you've got a big ass bank of different Sprague capacitors. Look at that. That is a diode. That's my thumb right next to that diode. It's giant. More diodes. Oh! Look at those turquoise capacitors right behind there. Those are some high voltage capacitors. There's 2 of them. Oh wow, look at that. That looks like a ceramic. Yep, that's labeled Sprague. That has got lettering on it. Guess that's a really high voltage. That's a high voltage ceramic capacitor. You don't see that these days in CRT drivers. You've even got a trimmer on here. Oh, I twisted it. Now it's uncalibrated. Now I uncalibrated the entire scope, and it's not compliant anymore, as the European Union would say. Here's your cathode ray tube output. Guys, the only bad thing about European Union is that everything has to be like corresponding to a norm. And for example, the only knife that is compliant with the EU norms is, of course, guess what? A blunt knife. And I'm not kidding right here. Europe is just going way too far with their health and safety. But at least the electrical system is fine, or safe. Anyways, my legs are oiled. My oiled joints are hurting from sitting right here. Anyways, here's your inputs. You've got these really high quality Tektronix capacitors on here. Looks like some tunable capacitors, some gold-plated screws on there, of course. More tunable capacitor. Each one has a different number of plates, which is interesting. Oh, and look at that. I mean, you've got resistors on here. Look how that is neatly linked together. Finally, I can see some AF transformers. Jesus Christ. Anyways, a ton of trimmers, again, a ton of different tunable capacitors, a ton of stuff you could calibrate in this thing and also discalibrate. A ton of different trimmers. This is your invert switch, I believe. Yes, you pull that. Is it moving? Yes, you can see moving. That's neat. Anyways, these things right here, what are those? PNP. Are those transistors? And I guess that they are linked together for thermal matching, I guess. Those look like op amps right there. Those two, right here, those two devices. Is that beryllium oxide? Yep, it is beryllium oxide. How great. More beryllium oxide. More cancer substance. Anyways, more like ferrites for the interference suppression. Look, you've even got ferrites on the resistors. Jeez, isn't that something? And yeah, and you've got like an inductor on here. Really neat. Like, this is an inductor right here. Again, replace transistor. 2 more of these old transistors, like really old ones. And yes, so I guess that's it for this one, guys. I hope you liked it. Hope you learned something new. And hope you learned that you shouldn't break apart beryllium oxide. And that you shouldn't touch high voltage power supplies. And yeah, hope you liked this one. I'll see you guys next time. Bye bye.